Okay, hi Jenny. Quick video for this for you. Yeah, I totally understand why these questions can sometimes confuse. I find I make careless errors as well when I do it, so I'm going to do it all from the start. We've got 4m squared plus 4m plus 37 equals 0 for our characteristic equation. Dividing by 4 will give us that. Completing the square, and I know you've done this, but I just wanted to do it myself so I remind myself how it works. Gives us this, and that's a plus 9, isn't it? So when you rearrange this, you get minus a half plus or minus 3i. Cool. Okay, so that gives us h equals e to the minus 2t over 2 a cos 3t plus b sine 3t, and I'm pretty sure you did the next bit, didn't you? Now the next bit, one thing I did want to say is make sure you've got different signs here, because if the diving board's below but the speed is moving upwards, they should be opposite signs. So you've got t is 0, h is minus 20, and dh by dt is 55. Now plugging in t is 0 and h is minus 20 is no problem, because you get e to the 0, a cos 0, so that's just a, plus b sine 0, and sine of 0 is 0, so you get a here as minus 20. Lovely. Differentiate, this is definitely the pain point in the question. Differentiate that, minus a half e to the minus t over 2. This just takes forever. Times it by the other side undifferentiated. Let's put a in as minus 20 actually as well. That makes it easier, to be honest. So I'm not differentiating this side. But now I'm going to do it the other way around. I'm not going to differentiate this, but I'm going to differentiate the brackets. That's going to give me 60 sine 3t plus 3b cos 3t. And then we plug our conditions in again. So 55 equals, we're going to get minus a half here because we're plugging in t is 0. We're going to get minus 20 plus 0. And then we're going to get e to the 0 times by 0 plus 3b. Okay, that's quite nice, because that's 10, that's 45, so you're going to end up with b as 15 there. And so we've solved our differential equation to find a particular solution. We know that h equals e to the minus t over 2 minus 20 cos 3t plus 15 sine 3t. All well and good. Now, it wants the maximum vertical displacement. Well, best way to find that, particularly because we've already differentiated it, is to write down the derivative and set it equal to 0, because we're finding a maximum. So let's write down dh by dt, but with everything plugged in as before, as in a and b plugged in. We're going to have, and I'm going to actually factorize it from here, yeah? So from this line, I'm going to take out that e to the minus t over 2, and to point out we would have had minus a half times minus 20 cos 3t. Well, that's 10 cos 3t. Then minus a half times by 15 sine 3t. Well, that's going to be minus 15 over 2 sine 3t. Then we're going to have plus 60 sine 3t plus 45 cos 3t. And I'm going to combine those terms, yeah? So just so I've got it nice and neat and tidy before I set it equal to 0. I'm going to have 55, is that cos 3t? And then I think I've got 105 over 2 sine 3t, just because 60 is 120 over 2, and 120 minus 15 is 105, positive 105 over 2. Okay, now it's a simple case of setting this equal to 0 and solving it, yeah? And it's got a nice way to solve it, because we can turn this into a tan problem, just because that never equals 0, so we can ignore it safely. And this is going to rearrange into tan 3t equals minus 22 over 21. I did this a second ago. I think it's all right. So 3t equals, well, when you do it on your calculator, you get this value, but that's going to give you a negative time, so you don't want that, or 2.33, and that eventually gives you t is 0.777. And then if you plug that t value back into here, you can find a maximum displacement, and I think it comes to 16.7 centimeters. Hopefully that's cleared that one up, Jenny. Let me know if you're still confused, though. Very happy to do it. Yeah. And then what does it ask for at the end? Comment on the suitability of the model for large values of t. Well, One thing I would say is this is never going to stop vibrating, and so that's slightly unrealistic. But otherwise, it looks pretty realistic to me. So it's probably one of those questions where you can argue either way. Okay, thanks a lot. Thanks for listening. I better dash now, just because I've got an appointment. But yeah, all the best and good luck, Jenny. You can do it. You're doing superb. Bye bye.